In the previous video, we replaced our 3 volts power supply with 4.5 power supply and basic LED with RGB LED. Today we're gonna play with NTC. We're gonna use it to make basic overheating protection. This is an NTC Thermistor, one of the most common temperature sensors used in electronics. Right now I will explain how it works, and with a multimeter connected you can see how its resistance changes as the temperature changes. This way you can directly observe how this simple component reacts to heat in real time. So I will connect the NTC right here, like this. Now let's turn on our multimeter and set it on resistance measuring, and we have 10K. This is my NTC 10K. Now I will use the soldering iron to heat up temperature, but I won't touch the NTC because I don't want to break it. I will just hold it close enough to change the temperature. You can see the resistance is dropping down pretty fast. When I take it away, the resistance is raising up again. It works pretty quickly. Again, close. Resistance is dropping down, and take away, resistance is rising up. So this is basically how it works. It's just resistor sensitive to the temperature. There is one simple way to use NTC. We can just plug in between the base from the transistor and the ground, like this. One leg to the base, second leg to the ground, and now the NTC is controlling the brightness of the LED. We can heat up the NTC, and you can see LED stops blinking when we take out heat. The NTC is cooling down and LED starts blinking again, stronger and stronger. But we will make something better than this. We will make thermal protection. When the temperature will be high, the whole circuit will be shut down. So I will take out this NTC. To make our circuit protection, we will use a comparator like this one, LM393. A comparator is an electronic circuit that compares two voltages and switches the output depending on which one is higher. We will connect it right here near the power section. I will place it upside down. The notch will be on the bottom like this. So the pin number 1 is right here. The comparator and the MOSFET will be controlling the power of the whole circuit. So first we will move this jumper wire a little bit like this, and we will move the switch so it is breaking the line of the VCC from the power line to the comparator, and we will change this resistor 470 to the 3.9K resistor, and we will place it right here to the base of the MOSFET and between the switch and the VCC of the comparator, like this. Now when we turn on the switch, the comparator and the MOSFET will together get power. Now we have pull-up resistor and pull-down resistor at the same time on the MOSFET gate. So it's not good because they both will be fighting each other trying to set up the gate. To prevent this, we have to remove this pull-down resistor. So I will take out the capacitor now first, and I will take out this resistor and put back the capacitor like this. Now we only have the pull-up resistor. Now I will connect the ground from the comparator to the ground directly to the battery. Not this ground, but this ground directly to the battery. So I will connect it like this. Okay. This IC has two comparators inside, but we will use only one. So to prevent some interference from the second comparator, we will ground this, and to do this we will connect the pin number 5 and pin number 6 to the ground like this. Now let's connect the output from the comparator to the base of the MOSFET, because the comparator will be controlling this base. So connect it like this. Now let's set up our reference voltage. To do so, we will use the voltage divider. I will use 8.9K ohm resistor, and I will connect it to the pin number 2 and VCC like this, and 2.7K ohm resistor to the pin number 2 and ground. So I will connect it like this. Also the ground directly from the battery, not this ground. And now we have to connect our NTC. And also here we will use voltage divider. We will connect our NTC to the pin number 3 and pin number 4 like this, and I will use 1K ohm resistor, and I will connect pin number 3 and VCC like this. Now we have the 3.6 volts on the NTC on the pin number 3 and 0.9 volts on the pin number 2. This is our reference voltage. And when the voltage on the pin number 3 will drop down below the 0.9, the circuit will turn off. Now let's see if the circuit is working. I will take my soldering iron and I will heat up the NTC. The circuit is off. Now it's on again. Heat up. The circuit is off. Now it's on. So the circuit is working. Right now the circuit is working, but we have one big problem. The turn off level and turn on level of the voltage is basically the same. So if we have a tiny changes in the temperature, the circuit can switch turn on and off very quickly. To prevent this, we have to add something like the hysteresis. And to do the hysteresis, I will use 330 ohms resistor, and I will connect pin number 3 with pin number 1. And now with the resistor we have kind of delay with the action. The circuit is turning off a little bit later and turning back on later, so it's not at the same level. I connected the scope to the circuit to show you what is happening. The yellow line is our output. The purple line is NTC, and the light blue is the reference voltage. Now I will heat up NTC. You can see clearly the purple line is dropping down because the voltage is dropping down on the pin number 3, and when it drops below the reference voltage, the circuit is turning off, and when it rises above, the circuit is on again. Of course, this is just demonstration, and I don't know what the temperatures are when the circuit will turn off. And if you wanna, you can measure temperatures precisely and tune this circuit, change the resistance of the resistor, and it will work perfectly as you like it to work. But for now I think it's pointless, because right now, for example, if we burn the 555 timer, NTC is too far away and it will not react to high temperatures right here, because the circuit is opened, it's not in any box, it's not closed. If you wanna, you can tune this, but I think I will skip this right now. So now you know how you can protect your circuit from overheating. In the next video we're gonna use light sensor to control LED brightness.